Hello, hello. Good morning, everyone. Thank you so much to all of you for being here. My name is Sana Tariq, and I'm working in TELUS right now. I did my PhD in computer science a few years ago, and I have been working in telecommunications in different telecom providers last 7 years. Right now in TELUS, I'm working as a lead architect for end-to-end service orchestration platform and working on its architecture and long-term roadmap. Here today, my talk is about AI-driven orchestration. So before going into really the AI and machine learning and the closed loop part, I will first share with you the operational challenges of service orchestration platform. And I think a lot of those challenges will resonate with you because we are at a stage where we have already developed a cloud strategy, and we are going towards the pieces of automation and orchestration through multiple service provider networks and for a lot of services that we are working on. So the agenda for today's topic will first cover the service orchestration journey, how we are evolving, taking our baby steps towards the world of software-defined services. Next, I'm going to walk you through all the practical operational challenges for service orchestration and share the evaluation criteria, what we are looking at. And then I'll introduce you to the concept of closed-loop automation. What is a static policy? What is a dynamic policy? And through dynamic policy, how we incorporate artificial intelligence and machine learning, and what we are doing in the context of AI machine learning to try to build a future for software-defined use case and services. So going into this warm-up slide here, we are all familiar with the journey that we are taking right now to build a future of software-defined services where we will be able to deploy these services on demand, on the fly. These services will be short-lived, and that's a future state where we want to reach. But we are going through all these intermediate stages where we are taking baby steps. We were at once at physical network functions, then we started building our NFV cloud strategy, then we are gradually building automation and orchestration pieces into it. VNF onboarding is a very basic, simple use case for orchestration that a lot of us are going through these days, and we are learning all the challenges that we are facing. So gradually, as we are moving ahead this curve, we are adding some automated assurance pieces. We are adding artificial intelligence for some of the basic stuff like capacity and application management, and gradually we will be able to get to this end state. I want to spend a couple of more minutes indicating what this end state really means and what it would hold for us. When we are able to launch 5G or IoT kind of use cases, these services will be short-lived and on-demand, and we're hoping that we'll be able to expose those services to the end customer portals, and the end customers will be requesting these services and changing the requirements around these services almost on the fly, so we would be able to support intent-driven orchestration by that time. And those customers, for us, would actually be represented anywhere in the world. So you can imagine all the MEF inter-service provider APIs and all that would actually help us be at that end state where we actually want to be for a software-defined services future. This is another context-setting slide for us where we are setting up the foundation for successful orchestration, that NFV Telco Cloud is different. We have seen in all this previous summit and discussions that it's not like a typical public cloud. There are so many different types of services that a typical telecom service provider is supporting. Those services have their own unique requirements of latency, performance, and the constituent VNFs when they're actually going in the cloud would require that kind of performance KPIs from the cloud. So we need to design the NFV Telco Cloud in a way that meets all these features. So we would support a high throughput and much lower latency, for example, for our edge regions and for 5G types of services. We have to support 24/7 availability. And we need to support a lot of APIs so that the upstream orchestration and VNF managers can absorb those APIs and be able to use all the fancy cloud features. We're at various stages of development for all these features, but it's at least a goal that we need to support all of these features so that NFV Telco Cloud could become successful as an NFVI platform to support the software-defined services that a telecom service provider actually need to support in the future. A couple of additional points here. Security is also a critical aspect of NFV Telco Cloud. Agility is another aspect, and we have to do all of that while bringing the cost down and keeping the flexibility goals for building our cloud at the same time. You are very familiar with this diagram, and a presentation cannot be completed without having this HC. famous diagram. So I wanted to include that because I really like to reference it as I set a foundation and a context for the rest of the discussion here. First of all, as a foundation for this NFV SDN journey, the most important step is building this NFVI infrastructure, a robust, efficient cloud that serves as a foundation for doing almost anything else on our journey. The next part that I've highlighted here is the most challenging aspect of this journey. That is the stage where we have a number of different VNFs from a number of different vendors, and we are trying to onboard those VNFs onto cloud. And we know that the state of maturity of the VNFs itself today, the state of the EMS evolution for those VNFs, and then a bunch of VNF managers, specific VNF managers, in our journey towards the GVNFM, the standards are evolving in this space, and vendors are trying to basically adopt those APIs as they are becoming available. So it's a complex time for us to be able to do these things and do it in the right way. And I'll touch this more in the upcoming slides as well. The SDN transformation has been happening across the organization. That's another prerequisite. We would need all the network to be softwareized so that the software-defined services can actually use that softwareized networking foundation for its services delivery. Another important aspect is a shift in the way we used to do our OSS, BSS, our billing, our ticketing, alarm, and our analytics and service assurance platforms. The hardest challenge right now to be able to operationalize and take your first use case to production as a software-defined service. I think there is a lot of work that is required in these areas, and a transition and evolution is, of course, happening through many service providers these days for shifting these sites as well. And at the end, the most important part, the service orchestration that connects all the pieces together and performs the orchestration role, and of course is the focus of today's presentation. And we'll dig deep dive into the details of service orchestration as we go into the next parts of the presentation. Since we started this program, the dynamic landscape of the service orchestration has been changing rapidly. Within the last 2 years, I have seen a lot of open source projects taking shape, and a lot of open source projects increasing the size of its community. There are many commercial vendors orchestration products out there in space, and thought leaders, and I would say a very competitive landscape at this time. To compare the orchestration platform from a commercial vendor's perspective or an open source, the debate is still the same. For the commercial vendors, we have a relatively higher licensing cost, but at the same time, a traditional telco has a mindset that we want to depend on this 24/7 support model, which kind of gives us the comfort, and we're able to sleep through the night while doing all this transformation. At the same time, we are able to get more predictive releases for the softwares, and we can control their features. While if you look at the open source, there is a huge interest right now in the open source projects because the system that we are trying to build together has to be open, and we have to support the open source communities in the projects as well. We will have significantly lower licensing costs. At the same time, we will have to depend on ourselves or community, or maybe a third-party system integration vendor who can come in and help us deploy the open source project into our network. While we will not be able to control the roadmap ourselves, but the community together will control the roadmap. And another important aspect about open source is that the success of any open source project depends on the size of the community and participation of the community. So in the recent years, we have seen ONAP has received a significant amount of interest from community, and that's why we are developing huge amount of interest in looking at ONAP, doing our POCs in ONAP and trying to learn ONAP as much as we can. As we do every round of our POC, we make a list of our gaps and we send it back to Linux Foundation so we can contribute back in community our ideas and what our challenges are to be able to adopt ONAP. While we are working actively on the constant evaluation of commercial orchestration products as well as open source, and this is a very dynamic and active landscape right now, and interesting to see what's going to happen in the future. So I wanted to share with you some of the evaluation criteria that we have kept in mind while we thought about taking our first use case into production. When you are actually looking to operationalize your service orchestration platform and trying to put a real production traffic on it, you stop looking at those the fancy features, like, for example, 5G network slicing use cases or artificial intelligence-driven closed loop. You're looking at some basic functional requirements that must be there that would actually be sufficient enough criteria for you to put your production traffic on. So the evaluation criteria shifts a little bit, and then that's what it looks like. We are looking at a service design creation studio, an environment we will be building our templates and where our engineers and where our people will be spending a lot of time developing NSDs and VNFD packages. So that environment has to be really friendly, and it has to support the template creation in a way that is making it easier for us to build and validate those templates and be able to check some of the relationships offline and be able to validate those templates before we are actually putting that to use. So this is an important area where we should really be focusing on if we have to build a successful foundation for our software-defined services and our service orchestration platform. If you have a software-defined service which is actually exposed to an end customer portal, and the end customer is actively requesting those services, you need to have a redundancy architecture built into your orchestration platform so that you can provide the 24/7 support reliability for your services and your SLAs are not affected. The VNF testing and VNF validation is one area where I have found an industry-wide gap right now, and I have reconfirmed that gap by my discussions with a lot of people here from other telcos as well. So the very basic use case of orchestration is what? You can basically do VNF onboarding, adding your capacity to your network on demand, on the fly. That basic, simple use case VNF onboarding where we are at this stage is giving us a number of challenges. So if you're able to write a template and you can spin up that template and you can instantiate a new VNF and you can basically even achieve day one or day end configuration through some of the configuration scripts, and if all of that is done on demand and on the fly, but you have to spend another whole month of doing manual testing in order to make sure that application is up and running and it's working before putting your production traffic on it, it's not giving us a fast time to market. So this landscape of VNF testing right now has a huge gap in it, and it would be nice that all the VNF vendors can actually provide automated tested suite associated with each VNF type, and we could include that on the VNF onboarding cycle where we can invoke an API call to the testing tool and include that in our cycle. That would actually give us a VNF onboarding acceleration, and we could add that simple first use case to production where we can add new capacity on the fly. It's a very basic thing that orchestration should be capable of doing before we start building on it and start developing more advanced use cases like lifecycle management and lifecycle management of our services. The other important thing that we learned and wanted to, of course, share with the community that when you're trying to build a DevOps team and your DevOps culture, the enterprise licensing model is something that you really need to look for. There are a few vendors that are kind of supportive to that idea, but I think there are a lot of vendors which are not open to the concept, and maybe they're looking internally and trying to create a business model that would eventually support an enterprise-wide license. The general licensing model of the VNFs is also something that should gradually change to an enterprise kind of license, because you're adding the capacity on the fly, you're deleting your stuff. It's harder to keep track of the legacy ways of license management the way it was happening before. So it's an interesting topic which has been discussed in the ONAP community as well, and there are different schools of thought on that. And I believe that not having a typical way of VNF licensing or anything, the licensing model has to change. Then we will touch a lot on these analytics and policies side as well. This is another important area where we want to reduce the human intervention and include a lot of closed loop automation in our orchestration. Automated and thin, lightweight install of your orchestration product is another important criteria. The recent development of OOM module in ONAP is very interesting, and we will evaluate that because it has just been announced. A Tosca-based template where you can spin up the whole ONAP environment under one click looks very interesting. We haven't tested that yet, but I think it's a very good initiative from ONAP right now. The resource orchestration module is another important and a fancy feature of the orchestration platform, but as we are operationalizing our platform, we are realizing that we are not really there yet. There is a very limited set of APIs from the OpenStack, which actually provides the real visibility of your cloud regions when you do that Vim integration, and then a very limited visibility of available resources created under the resource orchestration module. So as the community is growing and improving on this resource orchestration as well as ONAP, I think it would be something really good for us to maintain and manage those resource and cloud regions in orchestration the way it was anticipated. Adapters and plugins, another important area of orchestration, where orchestration is like at one layer, it has to speak to so many downstream technology domains. They all don't speak same language. So there's one API language spoken here, another API's language spoken here. The data translation happens through developing these SDKs, which is going to be there for quite some time. So it's important to see the model by which these SDKs are provided to you. Do we have a model where it's a community shared plugins? You develop a plugin once and it's outsourced in the community and you can use it? Or do we have to use these plugins every time you are doing like a brand new development with your vendor? So I think these are the important evaluation criteria that we kept in mind while trying to build and operationalize a service orchestration platform. And we'll continue to validate ONAP and other orchestration platforms based on the same criteria as we are constantly evaluating and constantly assessing the market. So some of the things which are really important for building a successful service orchestration platform, as we already discussed, one is a robust cloud and with a lot of automation features, having a lot of APIs and elasticity. Then having an SDN controller, and by saying that, don't have SDN controller like just theoretically. We have to have a complete softwareization of network. If you have an SDN controller, but somehow your IP address allocation is still manual, it's not giving you the type of agility that you want to have your software, your VNFs created on the fly or software-defined services created on the fly. So a complete softwareization of configuration of your external network, your IP address allocation, and then if it's not actually there and there's some still legacy equipment around, need to have workarounds in place until we actually make that shift and transition towards a full softwareization of our network. Another important building block, or I would say a foundation for successful service orchestration, is the change of analytics everywhere. As service orchestration has to perform healing and scaling, we need to ensure that we have the right level of visibility into KPIs from every different layer of your network, from your cloud, from your applications, from your VNF managers, and then the orchestration platform itself to be able to perform the functions of healing and scaling. So there is a huge work that has to happen and would serve as a foundation for the closed loop part that I'm going to discuss in detail in the next parts of presentation as well. A transition to the DevOps culture. DevOps is needed for orchestration, and orchestration is also an enabler of the DevOps culture. Faster time to market, agility in your work, doing small changes on the fly, and incremental in every approach that you take. I think that's the same philosophy that we are sharing with orchestration as well as in the DevOps culture. Data models is another important aspect which is going to serve as a foundation for successful orchestration philosophy. Homogeneous across the stacks and consistent data models for seamless integration, and having fewer information models and consistent information models will actually help us deliver the abstraction that we need to ensure for software-defined services delivery. So this slide is interesting, and I'm going to spend some time on that because when I spoke to different service providers here, I felt that the problem resonates with so many of service providers outside of our network. So when a typical telecom service provider starts the journey of NFV and SDN, we have a lot of different technology domains. And for example, a VEPC network, we have an SD-WAN side, we are building our cloud, we could have enterprise network, and we could have IMS network, for example. And each of these discrete technology domains have a number of vendors represented in it. Every vendor is trying to take its own journey to virtualize their applications, to build their specific VNF managers, and every vendor is also developing an orchestrated platform. So when you look at this landscape and when you look at how these use cases are evolving, you feel at a point that there is no one size fit all. You cannot have one orchestrator that meets the goals of every single technology domain. So it seems like you end up having a controller here, you end up having a specific controller here which talks netconf. You would need specific controllers here which has a better resource orchestration, and different types of solutions actually support these use cases better. You end up having a huge mess of controllers, while ONAP is driving a vision of providing you an architecture where you have specific modules, like for example, app C can have all the specific VNF or GVNFMs underneath that, and then for example, you have a software-defined networking controllers layer where you can have all your software-defined networks there, but actually it's not all that easy to basically use ONAP and start building that architecture. While it's going to drive our direction in the right direction moving forward, but I think this will still remain a challenge as we are trying to build a clean architecture to support all of that. We need to build an abstraction layer that consumes all these other controllers and still be able to provide an end-to-end orchestration, because we are looking at a future where we want to have all these software-defined services which would support intent-driven orchestration, and at the same time we want agility in the templates that would be abstract and written in a higher layer language, and we should have enough enough generic interfaces in all these layers to be able to achieve that kind of dream. So going forward, I think what the takeaways from this challenge for us are that we want to reduce the number of specific VNF managers in each of these domains. We also want to reduce the number of controllers and vendors because we want to reduce the total cost of ownership as we are operationalizing the platform. And we want more standards, and we want open standards so that if we have to replace one of these layers and these interfaces are actually standardized, we will have the ability to do that. And industry-wide, it's a challenge, and I think it's a common challenge, and I wanted to share this with the community so I could learn more about other organizations as well. So this particular slide actually takes a step forward into the future. Assume for a second that we have actually reached a stage where we have already gone through all our challenges, and we have now software-defined services in production. We have a lot of software-defined services in production. The way we felt that NFV is going to reduce cost, which we didn't see right away, and there's still a curve to that, you will actually see a lot of people and your employees and your work effort invested to the troubleshooting problems when the software-defined services actually get into production. The reason is that the changes will be happening more frequently now. And now you also anticipate that your workloads are not sitting at one place. The workloads, if you're doing this lifecycle management, is shifting from one cloud region to the other cloud region. And as we also felt that those services will be short-lived and created and destroyed on the fly. When you're trying to support all of that, the data volumes and the patterns within that data volume will be very significantly different than what we have been used to doing. As a result, the amount of people we were using to troubleshoot and solve these production problems is not going to reduce, it's going to increase. So that's the part where we say that we need to look into our closed loop strategy, and where we need to look at our artificial intelligence machine learning on that set of data sets so that we can actually reach a future where we will be able to leverage those powerful technologies and help reduce the manpower for the intensive troubleshooting for that kind of situation. So we are doing a number of POCs, and ONAP is very promising with this DCAE module where we can actually play around with the dynamic policies and machine learning. I want to walk you through the very first flavor of a closed loop orchestration. This particular diagram is from very first version of ONAP, where eComp, and this was on the ONAP wiki as well. It's a basic use case which was available for use for everyone, and we did this POC last year. So what happens is that you have a firewall, and the firewall, we have a static policy defined here, which says that if this firewall reaches 80% of utilization, you will have an action associated with your policy to be able to perform a scale-out action. So this is how it works. Initially, your traffic is smooth, nothing happens. The VAS collector takes the KPIs from your load balancer in your virtual firewall. As soon as you hit the 80% mark, the analytics sends a threshold to the policy engine, and the policy engine with the service orchestration and VNF manager performs a scale-out action and gives you a new firewall instantiated on demand. This is a very simple example of a static policy and a static action associated with that. We have statically defined that 80% is the mark where the scale-out action has to happen. So the world's not going to stay that simple. We will not be writing the static policies the way we have done so far. And the focus of ONAP has also been so far writing policies in a static way, and mostly focusing on the VNFs and mostly focusing on the service scale in and scale out. What we wanted to try out in our POC is to shift that focus a little bit. We wanted to do something with the cloud optimization for performance and cost, so we will write the policies in a different way, and we will test and try some different use cases assisted with AI and machine learning. Taking you to the landscape of dynamic policies and assisted with artificial intelligence machine learning. So your analytics space is going to change dramatically over next few years. Your cloud analytics will shift your security analytics will shift, the services will shift, and the user demographics will shift with the launch of IoT. When all of that happens, there's going to be a huge surge of data, and there's going to be a lot of hidden patterns within that data which humans will not be able to understand and perceive. So it's important for us to have a framework where we are consolidating that data, and we have artificial intelligence and machine learning libraries where we have a framework to be able to perform some predictive analysis and proactive analysis. And at the same time, we are looking at a strategy in our policy to write some policies which are not reactive, and the policies are actually written in a dynamic way. If we do not do that, we will end up having a lot of policies in a reactive way. We might have a lot of policies written in a way, and we might end up having a policy conflict. And then we might have to basically resolve those conflicts through some other additional ways. So writing fewer policies and writing dynamic policies would be a much better way for doing closed loop in the future. And with the closed loop, you can basically associate your actions to any of these regions, either do something on the cloud for cloud optimization, either scale in or scale out your services, or mitigate a security attack or event, or maybe optimize your network. So we will talk about some of these use cases now. So first of all, what do we need for AI machine learning orchestration? And why do we need it? For the first is the launch of these services and huge data surge, which is expected to happen. Then the static policies will be too many reactive decisions, there'll be too many false spikes, and we don't want that to happen. How can we do AI machine learning driven orchestration? We need to have a support from DCAE or ONAP modules to be able to do dynamic policy. And at the same time, we have to have a large volume of well-organized, good data to be able to run our AI machine learning algorithms on it. And we have identified few initial use cases for our learning and for investigation. What we can do with AI machine learning driven closed loop is that we can deliver our services closer to edge. We can perform all the service healing and scaling, and we can also provide differentiated quality of service to our end customers. For the cloud optimization and performance optimization, we can do energy optimization, capacity optimization, and fault prediction. Similarly, within TELUS, we are already working on different programs within different teams who are using machine learning for network optimization right now, and the traffic optimization providing QoS-based routing. Another important, interesting area for the machine learning early adoption could also be security, to provide proactive and predictive threat identification and do some of the closed loop decisions on mitigating the threat attacks. So before I go into the architecture of ONAP and to build AI machine learning driven closed loop, let's take a quick look at how do we actually build AI-based application. The real first step of that is a problem definition, where you identify what is the problem that you want to solve. The second step is gathering real sizable data volume. I was at ONS conference a few months back, and something that I learned about AI machine learning was that data is going to be extremely important asset for any organization. Data is going to become something like gold, and the organizations which has a huge volume of data are even going to sell that data to the ones which do not have sufficient volume of data. So data is extremely important, and organizing that well in time, I think, is an important foundation for developing your AI machine learning strategy. Preparing the data, cleansing, normalizing, and feature extraction. How do we basically prepare the data where AI algorithms can actually run on it and gain their training from it? You need to normalize the data. For example, the data can have a range of values within that. You need to remove the outliers. Like, for example, if one of the value from your data has a very significantly high or low number, that kind of parts have to be removed, because it's going to not help your algorithm learn the right way. And similarly, you have to bring the data in the right format. So that part is called preparation and cleansing of your data. The training phase is the hardest step, which is the compute intensive step, and after that, once the model has been prepared, you have a percentage of your data. You split your data into two parts. The first part, 80%, is used, for example, for training, and the rest of the 20% you can basically use to test and evaluate if the model is successful or not. And then you know the answer, you will run it through the algorithm once again, through the model, and see if it's coming to the predictable output that you're looking for from it or not. And at the end, the evaluation of the predictor, and you go back to the loop of testing it, modeling it again, in case your model is not correctly configured or hasn't learned the right thing yet. The good thing is that AI is actually becoming easier. It is a very old technology and has been around since 1950, but recent years have actually improved the way we use AI. So in the old times, data scientists would spend a lot of time in looking at these mathematical Bayesian or neural nets, the raw algorithms, and going to the nitty-gritty of mathematics to be able to do something. But as we are looking the Spark kind of libraries where we have Python and algorithms already written for us, we can just use those libraries and some of the projects, for example, H2O TensorFlow from Google, where we have complex coding already done for us, and we have only Python libraries to be able to use those simple APIs to invoke these algorithms. We actually don't have to do the mathematics of complex algorithms that people would actually do in the past. And even better, 80% of a data scientist's time is actually used in helping training the algorithm and developing a model, which is actually then eventually used as a key for testing your new data on it. The recent launch of Linux Foundation project Ecumos is actually an idea where different service providers and different companies can come together and bring their data and share their data, and you can have a model which has pre-learned the outcome, and you can just use that model without having to worry about training it or using your data for it. And you can invoke an API call to be able to use that model. It's a very new project. A very few service providers have actually joined it. There are more joining these days, and Linux Foundation is asking for more community support in Ecumos. I'm personally very interested in Ecumos, and I'm looking forward to participate more in their in the work in the future. We have to have data available. Now we have more data available, and it's much better than before. That's why AI is becoming easier, and the computing power has also improved a lot since last. So that's why we are hearing these buzzwords of AI machine learning much more than before. So this is the architecture for our ONAP based POC that we are working on these days. So basically, we have started simple. Taking a first baby step, we will focus on DCAE module of ONAP. We will just get 2 OpenStack projects where we have Cloud Region 1 and Cloud Region 2. We will be building our policies on the cloud optimization. So this particular use case is going to serve as a foundation for us to learn how to write dynamic policies and how to learn the best algorithms for AI machine learning that we can actually leverage for our cloud optimization use cases. I'm going to walk you through a flow of how this actually works. So first of all, you define a service in your ONAP SDC environment. You define a closed loop control in CLAMP. And if you can do it either with GUI or you can define it manually, depending on what the kind of policy are you writing. Once that is done, it gets pushed to the SDC, and SDC sends it to the DCAE, and it gets published on your policy engine as well. At the same time, if you have 2 cloud regions, and these cloud regions are creating data, your ceilometer data can be fed into the VAS collector. The DCAE can absorb analytics from almost any source, but you need to develop these VAS collectors for it. This ceilometer is going to format the data and send it to the Hadoop cluster, which is another microservice within the DCAE. The DCAE AI microservice has the Spark library built into it, so you can start using the Spark algorithms and use a number of these algorithms to see which one works best for the type of use case that you're building. And once you have identified a situation that has to take action by the policy engine, that's going to be published on your DMAP bus. And the policy engine will take action now that the trigger has received, and now it has to, for example, shift over some workloads from this cloud region to this cloud region, and it will ask the service orchestrator to basically delete the VNFs from here and bring them here. So the trigger has happened from the cloud analytics, not by looking at the VNF level analytics in this use case. We are working on this POC right now, and we are looking into various use cases, how we can optimize our cloud resources for energy, for performance, for latency, and how the dynamic policy can actually be shifted around by taking some of these use cases. So this is another important slide that I want to spend some time with it. This is the work that we are doing across the industry right now to support these use cases and to be able to support some of the future use cases around AI machine learning. The concept of QoS-based routing and networking has been well established and has been well adopted in SDN controllers. The idea behind that right now is that when you look at cloud, and the cloud receives a number of workflows from the upstream software-defined services like these workflows also have a relative priority, and so those workflows should also be going to either one type of cloud region or other type of cloud region based on the type of service it has to deliver. So for example, if you have an IoT service that has a dependency that this particular type of service has a constituent VNF that has to go closer to the edge, it can be identified with one color. Then if you have another type of service which has a real-time traffic dependency, that particular VNF has a requirement, it has a real-time service requirement, so it has to go to a cloud region which is configured to serve these performance KPIs. Similarly, if you have a downloading service, the downloading service does a high throughput, and you don't need to have it in real-time performance, so you don't want that to, for example, go to your edge cloud. So you have identified a number of, for example, service types within your telecom service provider, and each of these services are represented with the constituent VNFs. We have taken a study with ERIS right now, and the proposal is going in the TOPS Council, which is approved, and we are looking for additional members who would contribute in that study right now. So basically, the first candidates for that study are MME, S gateway, P gateway, where we want to learn that what are the performance characteristics of these VNFs from cloud. What does it need from cloud? What type of latency? What type of network optimization, disk optimization is required for optimal performance of that type of VNF? Once that's done, we will work with HC to be able to associate these color tags with the VNFD packages, so we can classify a VNF type to a particular type of VNF that the class of service it requires, for example, from cloud. And ONAP, we are working with developing dynamic policies through the POC, which we will outsource back to the community once we have done that, that work to support the POC. Also leading some work in the ECUMOS right now to be able to provide the cloud optimization use cases. And we would need our policy to be able to look at those VNFD packages and to mark these colors and identify those. So the policies can be written to perform the initial placement into the right cloud regions for that. And then the policies can also be written to optimize some of the traffic in these cloud regions. For example, your edge traffic is moving here and there, so it can transition the workloads from one edge region to the other edge region. This whole industry landscape is a work in progress. We are also including a couple of universities which will do additional research on identifying the optimal configuration of cloud regions, how to optimize it for performance or for energy or capacity. We are inviting them to basically contribute to that, and a couple of universities have already approved, and their research university students will be working on their research to be able to advance this use case further. If you're interested in collaboration or you're interested in working more in any of these industry verticals with us, you can always reach out to me and I'll connect you to the right community where you can learn more and where you can basically participate more. And looking forward to comments, questions. Thank you. I think we have 3 minutes in case there are any questions.
Hi, Sana. For the use cases that you mentioned in here as far as the AI and closed loop automation, are you looking more on the wireline side or a converged sort of solution across the board, wireline and wireless?
So eventually, anything that falls under orchestration could become a candidate for a potential use case. What we have started looking from are the cloud optimization use cases, so both cost and performance. Once we have made some progress with that, I think we will start looking more into the services level use cases where provide better quality of service for wireless customers. And converge, I think, would be a much later on our roadmap to start looking into, as they will be later ones to be actually a part of our orchestration program.
Earlier in your talk, you had a box for a design studio. Are you using something there now? Do you have something, or is that a work in progress?
So the design studio that I mentioned in a couple of my slides, one was the evaluation criteria. There are many commercial orchestration products which kind of provides you the design studio kind of environment where you can go in and develop your basically templates and validates your templates. There are many commercial products which already have that. that are automated tools basically that helps you develop your templates there. We can discuss more offline on that. And the Design Studio also in some of my slides referred to the ONAP SDC environment. And ONAP SDC environment is like up in there, it's for everybody to use. It's not fully complete yet, but it has a very good vision, and it's like kind of slowly building towards a more automated way of developing Tosca templates there.
So I had a question about your area of artificial intelligence, and in your presentation, you're showing that you're doing that data analysis at the layer of abstraction all the way up at the end-to-end service orchestrator. And my interest is, why did you pick to do it there opposed to at the EMS level, where at the EMS, you have a lot of that domain-specific knowledge of what you're deploying? So like if we're talking about a network, yes, it's a network, but we may be looking at throughput and information like that, where EMSs are often very tightly integrated with their VNFs and their alarms, and then they could initiate automatic healing back to the VNFM.
I think the diagram maybe did not explain that very well.
Okay.
Basically, the DCAE module of ONAP has a model that basically absorbs analytics from every single domain. And as you said, EMS is one of those potential candidates where we can absorb analytics into the DCAE module. So EMS has very specific application-related data, and that data is extremely important to perform any action on that particular application. So the framework actually absorbs data from many different sources, and it's also kind of misleading to feel that this DCAE module is actually bringing everything into orchestration. Imagine the DCAE block is running somewhere outside of the orchestration module and just providing inputs to the orchestration. So that would be kind of a better architecture to think of.
Okay, thank you.
Great presentation.
Thanks.
I always appreciate TELUS thought leadership in this space. I have a question. How you guys are dealing with vendors who are a little bit behind on complying to the standard interfaces on that C? So what's your approach on?
Arvinder, I would ideally want to do things faster, but where standards are behind, we are kind of waiting for some of them to actually come up and meet those standards. For example, our SOL 3 compliant APIs or SOL 2 compliant interfaces, because if standard is already closed and it's there, it's better to do it once rather than doing it in a proprietary way once and then redo it again. So I think we are kind of pushing hard on doing it in standards way, specifically for the production stuff that we are planning on. For the POCs, we can do stuff even outside of standards, and if standards are not mature, we can do stuff the way we want. But I think for the real production stuff, it's ideal to consider if a standard is out, we follow the standard and push the vendors, of course, to actually develop those APIs and support those standard interfaces for us. Thank you so much, everyone. I'm getting time's up.